Hello everyone, we are pleased to present this research project, Agent Planner, which is an agent-based timetable system. So this study explores how multi-agent systems can provide a better approach to timetabling, especially in educational institutions. Let me begin by introducing our team. We are group number 8 and our team members are Idrivikrama, Nipun, Prabuddhika and I'm Vindhyan. So moving onto the agenda, first of all, we will begin with the background of the research paper and also its authors as well. Then we will move on to the problem statement. We will going to introduce agent planner system and its architecture. And then we will going to explain their research methodology, evaluation and results. And finally, we will wrap up the conclusion as well. Moving to the authors and publication details, as you can see, this research was carried out by the team of 3 researchers affiliated with 2 respected institutions, the Polish Academy of Sciences and the Warsaw University of Technology. Their study focuses on an area within computing and informatics and was published in Informatica, which is a well-recognized peer-reviewed informational journal. Here, peer-reviewed means that the paper was reviewed by other experts in the field before it was published, which means that ensure the quality and reliability of the work. The paper was appeared in volume 40, number 1 of journal, and in the year 2016. Since its publication, it has cited multiple times by other researchers and scholars, and as of June 2025, it continues to receive attention. This shows that the work has made an impact in academic community, and it is not only being noticed but also used by others in related studies, which highlighted its value of the relevance in this area of research. So overall, this paper is considered a meaningful contribution of its field. This is the end of my part. Now I would like to invite Nipun to continue the presentation.
Thank you, Indiani. Let's discuss problem statement. Let's now look at the core issue this research addresses. In educational institution, timetabling is a complex and repetitive task. Most existing timetabling systems are static. They cannot easily handle unexpected changes. For example, if a teacher calls in sick, many current systems need the entire schedule to be manually reviewed. Other tools like FET or those using agentic algorithms can generate schedules but lack flexibility. Manual updates are time-consuming and error-prone. Therefore, institutions need a smart system, one that can adapt automatically, quickly, and with minimal human effort. Okay, let's talk about research question. Now let's take a closer look at the main research question behind this study. Can a decentralized agent-based system create and update timetables more effectively than traditional method? In simple terms, we are asking whether using a system made up of multiple small decisions making units or agents can do the better job at managing timetables, especially when certain changes happen. Traditional systems often require one's central control and struggle to adapt when something unexpected occurs, like a teacher being absent or a room suddenly becoming unavailable. But in agent-based system, Each part, like teachers, room, or session, can make its own decision and adjust by communicating with the others. So this research aimed to find out, can such a system handle real-time changes smoothly? Can it reduce the amount of manual work? Can it improve overall efficiency and user satisfaction? By answering this question, we want to explore whether decentralization and smart communication between agents can offer a more flexible and reliable solution to modern timetable problems. Okay, now I invite to Prabhuddika to continue this presentation. Thank you.
Thank you, Nipun. Now, let's look at what is agent plan. To answer this question, the research proposed agent planner is a smart system that helps to create timetable based on multi-agent technology. In this system, each important part of a timetable, like teachers, rooms, and session, is handled by a separate software agent. These agents work independently. This means they can make their own decision based on rules and their preference. But more importantly, the agent can also communicate, negotiate, and collaborate to create the timetable. This makes the system more flexible and capable of responding to real-time changes. Here, you can see Agent Planner use case diagram. It shows how different users and agents work together in the Agent Planner system. Next, let me explain a bit more methodology. Considering about how Agent Plan works, here you can see there are main type of agents: teacher agent, room agent, and session agent. The teacher agent manages the availability and preference of each teacher. The room agent keeps track of room schedules and capabilities. The schedule agent acts as coordinator, ensuring agreements between other agents. This agent negotiate process goes like this: propose, evaluate, accept or reject, renegotiate, and confirm. So, for example, a teacher agent might suggest a time, then the room agent checks if the room is available. If not, they talk again and try to find another option that works for both. This is called negotiation. This system is flexible and smart. This is distributed in its decision making. If something changed, like a teacher suddenly can't come, it just change that part. That's affected not only whole schedule. This is called partial regeneration, and it saves a lot of time. So, overall agent planner is different from normal scheduling softwares because it is adapt to changes. It respects everyone's needs, and this support dynamical real-world scenarios. Now, to explain more about these things, I will hand over to my colleague Ediri Vikram. Thank you.
Thank you, Hashini. Let's move on to the next slide. Evaluation and results. The researchers tested the system in realistic settings. They found that the agent planner was more effective and flexible than traditional systems. It resulted in It resulted in greater satisfaction among teachers because their preferences and constraints were better respected. Students also benefited; their schedules became more continuous, with fewer idle periods between classes. And another important result was that the system performed well, even in the face of unexpected disruptions like teachers' absences. It could recover quickly and continue functioning efficiently. This proves that Agent Planner is robust and applicable for real-world use. Let's move on to the next slide. Conclusion. To summarize, the Agent Planner successfully demonstrates how a decentralized agent-based approach can improve the way educational timetables are managed. Compared to traditional systems, it offers better flexibility, faster adaptations to change, and higher user satisfaction. It meets the challenges of modern institutions where schedules often change due to unforeseen events. This makes Agent Planner a valuable contribution in the field of educational technology and intelligent systems. And thank you for your attention. This is the end of our presentation. We hope this presentation has helped you to understand the power of agent-based systems in solving complex real-world problems like timetabling. Thank you.